Okay, so let's move on to question number 9. What is the Balmer-Rydberg equation? Okay, so I'm just going to write it out down here. I'm going to write RH to show that this is the Rydberg constant. Then I'll explain what these variables mean as well. Okay, so this is the Balmer-Rydberg equation. So lambda stands for wavelength. And the units are in meters. Okay, so like I mentioned earlier, this R is the Rydberg constant. And it is 1.097 times 10 to the 7 inverse meters. So this NF is the principal quantum number of the initial state of your electron. Oh, I mean final state, sorry, this is NF. And then as you can guess, Ni is the principal quantum number of the initial state of your electron. So sometimes you'll have a question where they ask, like, what is the wavelength when an electron goes from a quantum state of n equals 4 to n equals 1? Then you would just plug it into this equation and then solve for wavelength. Let's see what our junior tutor said. The Rydberg formula calculates the wavelengths of a spectral line in many chemical elements. These wavelengths are formed when an excited electron from a higher energy state returns to its ground state and releases energy. Specific wavelengths or frequencies or energies could be predicted based upon a constant and 2 integers. The interpretation was that one integer represented the initial state and one integer the final state. The wavelength or frequency or energy was related to the change that occurred moving between these two states. Yeah? And then they have the Rydberg equation is represented as this, where lambda is the wavelength of electromagnetic radiation emitted in a vacuum. R is the Rydberg constant for hydrogen. And I is the principal quantum number of the initial state of the electron, and then NF is the principal quantum number of the final state of the electron. So this solution is correct.